Hi, welcome to Medical Physics Minutes, where Sun Nuclear's physics team takes you through timely topics related to quality management and patient safety in radiotherapy. Today's December discussion is going to highlight one of the recent publications from the MPPG lineup of guidelines. Medical Physics Practice Guideline 8B is on linear accelerator performance tests, and kind of in line with 8 is kind of a continuation of 8A. It's a 5-year update from 8A. It's influenced largely by TG142, TG198. There's some collaboration with the Royals Group, Working Group 100. The original FMEA was kept from 8A, but evaluated to ensure that the tests that were selected and the tolerances that were selected were relevant still to that FMEA approach. It was not repeated in 8B, but rather re-evaluated from the work that was done in the 8A document. Great care is taken to evaluate the performance tests based on clinical patterns of use that are relevant to detecting errors in that clinical use case. So really thinking through what could go wrong, what types of errors, what types of treatments are we doing, and how can we most effectively capture errors before they are a problem. It's not for CR, it's only for CRM-Linux, not for imaging, not for SRS. Those have different guidance documents. Action limit is used rather than tolerance. I'll have a discussion here on using the planning system data as the primary data source. MLC tolerances ought to be tighter based on clinical use of the machines today, and some of the standards have tighter tolerance as well, depending on machine type again. An exciting collaboration with the Astro Group Royals themed reports on equipment quality assurance was evaluated. We had a real good look at this particular document, parsing through the Royals database and pulling out specific events with particular keywords. So these keywords, 686 of them, included things like isocenter, alignment, update, service, energy, MLC. And so these were characterized and stratified. And so you can see this first graph is really looking at what are the keywords and the incidence in the database of those words. And then the second graph is kind of grouping them by a particular category. The largest groupings were identified as isocenter, alignment, Winston-Lutz. It's very important to make sure your QA, that your alignment for your patients is being QA'd appropriately in your system, in your department. And then update, upgrade, service, and technician. If you combine those two categories, groups B and C, that's actually the largest group. This would indicate that return to service QA is critical. Kind of restating this slide, the largest source of events from an equipment quality assurance perspective in the Royals database had to do with errors associated with updates, upgrades, service, and technicians. So what does your return to service protocol look like? That was a big influence of some of the tests that are done in this guideline. Primary reference data, we treat the patients with the planning system data. That's kind of the key. This is not the first group that has highlighted the data set, the primary reference data set, as your planning system data set. TG198 suggests this, TG135 says it specifically. So it's important to compare back to your TPS rather than your original acquired data. Things like your secondary reference data sets, daily QA, IC profiler, monthly QA devices, other things like this might be a secondary reference data set, but everything should point back to that primary data set. It's also noted that it's important to go through an MPPG 5 planning system commissioning process. You need to understand the accuracy and limitations of your TPS. And so you have to have done that first in order to appropriately utilize the TPS as your primary reference data set. On some of the test updates, often we skip to the tables to see what's different, what's new, what should we be changing. And so I've got a handful of slides to kind of look through this. The chair of the group really did a lot of work to make this table relevant, kind of the progression of tests from 142 to 8A to 8B, what was added, what was taken away, where were tolerances adjusted. And so we've put this into this format to hopefully help guide what's changed, where, and why, and what do I want to implement in my clinic based on my Linux use. So The outputs, profiles, and energies for the most part are the same. A couple of the relative output factor things for cones and field size have been removed from 8A from TG142, and 8B maintained that removal. But for the most part, these tolerances are pretty well defined and not largely changed. Green would indicate the tolerance is loosened. Red would indicate, green, that it's a new test or tightened a tolerance, and then red indicates that a tolerance is looser. More interesting on the relative output tests, where there was really a better emphasis put on some of these relative things. Outputs per cardinal gantry angle, linearity, constancy per gantry angle, with the relevance of VMAT in everyone's environments, ARC therapies, we want to make sure that those are appropriate. Also, I've called out these 3 tests down below. Dynamic delivery, this is basically VMAT testing monthly. D11 would be down here at the bottom, small field defined field size output factor, so something that's important if you're treating stereotactic cases. This is also in MLC1, so depending on your clinical use, if you're using JAWS to define small fields or MLC to define small fields, the test might be more appropriate. And then finally, MLC, this is now a tighter test. MLC was put into the mechanical category for 8A and then placed back into its own MLC category for 8B. Different things within the mechanical testing. You can see ODI is an interesting one. I like to think through this. There was a publication by Ford et al. That looked at how the sources of errors, the probabilities of errors, and what can be most effective at catching errors. And ODI is still on that list. Is the SSD different on the patient? It's a good way to catch errors clinically. So that is noted as a monthly test, both in 8A and 8B. Other things, light radiation, light rad testing, not necessary any longer as it was per 142. 8A put it as after service. 8B puts it as annually. So it's just a kind of a consideration of what's your light radiation. Kind of coming back to how are you setting up the patients, how are you setting up your QA equipment. It might make sense to include that as a particular criteria for these tests. Finally, Winston-Lutz is in here as compared to star shots. The different mechanical isocenter tests were removed from 142 and 8A with a preference towards Winston-Lutz if possible. Also, robotic couch is called out now specifically as a test. A lot of facilities are utilizing robotic couch movements for patient treatments, and those ought to be QA'd on a daily and an annual basis with the tolerances listed here in this table. Next, safety tests are on the list. After service is kind of noted a couple of times. Do things close appropriately? Your standard safety tests. But this new one, S7, as an annual basis, kind of thinking with an FMEA mindset. What types of tests are there? What things could fail that I should test on an annual basis? Things like the couch loses power. Do we test that annually? The door loses power. Do we test that annually? So kind of thinking through your emergency procedures as if it's like an HDR suite almost. What should we use for appropriate QA for safety tests? Wedges, MLCs, and comprehensive review of machine settings each get their own categories here. Things like the selected angle for your EDW test, what's being used clinically, not necessarily the maximum angle, but what's being used clinically, and then looking for the off-axis factor to report that appropriate angle to your wedge. MLC tests are pulled out specifically here, looking at different factors that kind of build out that robustness of the MLC testing. So MLC now gets its own category again, as it had in 142, and there's good data to indicate that should be tested routinely. So hopefully this suite of tests is helpful to review. If you want to read the full publication, it's in the Journal of Applied Clinical Medical Physics. Feel free to reach out to one of your subnuclear physicists. We're happy to walk through these in more detail as well. Thank you, and have an excellent day.